Drum roll, please. Right. We all know I'm musically challenged, so we'll stop that and let this lovely slideshow do it for us. Today and the next couple of days, we're going to be discovering probability. This is probably, get it? My favorite unit. It is so fun, and there's so many real-life applications of this, so get ready to have an adventure. First, let's start with some basics so that you guys have the definitions. And as we're going through this, guys, if you will grab the first station, you might get some answers to some of the problems that are already provided for you. First, we're going to start out with the definition. This is something you're going to need as well. So probability is a measure of how likely an event is to occur. For example, today there's a 60% chance of rain. As you look outside, we might be able to determine if this is true or not, but it is a claim that I am making, so the probability that I'm using is measured in percents, 60%. The odds of winning the lottery are 1,000,000 to 1. So this particular measurement that I'm using for the event to occur is numbers in a written form. And I would like you to take a moment to think about what are some of the examples of probability that you know. You will need to know this because it's going to be an exit slip. So think of an example of probability. Probabilities are often written as fractions from 0 to 1. This is the idea in Station 1 that we're going to discover a lot more. They can also be written as decimals from 0 to 1. When we consider an event and if it's likely to happen, if it's 100% sure it's going to happen, the fraction will be 1 and the decimal will be 1. So if that's the case, what if the event could never, ever, ever occur? How would we write that? Perfect. With a 0, as simple as that. 0 means it cannot occur, and a 1 means that it will absolutely 110 always happen. If we do percents, it's the same idea. 0% means it cannot ever happen, and 100% means that it will happen. So, as I just talked about, if it is certain to happen, then the probability of the event will be 1 if we are writing it as a fraction or a decimal, or 100% if we are writing it as a percent. If it will never happen, then the probability of the event to occur is 0 or 0%. If an event is just as likely to happen as to not happen, then the probability of the event is 1/2 and 5/10 or 50%. Here we can see a very nice diagram that I would suggest you guys write down, and it gives us the idea of what it is when we're writing a probability in number sense. If it is impossible, 0 or 0%, as discussed. Unlikely can vary. Right here it's represented at about 1/4, but that can change. Equally chances is 50%. Likely would be close to 3/4, and if we're certain, it is going to be 1 or 100%. When a meteorologist states that the chance of rain is 50%, the meteorologist is saying that it is equally likely to rain or not to rain. If this chance of rain rises to 80%, it is more likely to rain. With the same idea, if it drops down to 20%, then there is still a possibility it will rain, but it will most likely not rain. These are just a few examples giving you guys a real-life hands-on experience of where we can use probability. So what are some of the events that will happen and they will never happen, and therefore they have a probability of 0%? What are some events that are certain to happen and will have a probability of 100%? And what are some events that have equal chances of happening and have a probability of 50%? These are all some questions we want to remind ourselves of as we are continuing through the problem set that is for stations 1 and 2. When we want to write the probability of an event, it is written as P, open parentheses, the event, close parentheses, equals the number of ways an event can occur over the total number of outcomes. Okay. I know you're not tracking with me. So let's go ahead and provide an example. Here we're using the same idea. The probability of the event is equal to the number of ways the event can occur over the total number of outcomes. Example. I got ahead of myself. We're not doing an example yet. We're going to define those words there. An outcome is the possible result of a probability experiment. So therefore, when we're rolling a number cube, the possible outcomes are 1, 2, 3, 4, 5, and 6. The event is a specific result of a probability experiment. So it means that we've already rolled the dice and we determined what it was that the result was. So when we roll a number cube, the event of rolling an even number is 3 because we could roll a 2, 4, or 6. Still using the same setup, probability of an event is equal to the number of ways an event can occur to the total outcomes. And now we're to the example, guys. You know I get ahead of myself. So what is the probability of getting heads when flipping a coin? First, we have to consider how many outcomes do we have, which lets us know how many sides do we have on a coin. 2? Perfect. And then when we consider the sides that are heads, it is 1. So if you're writing this out, the probability of getting heads is equal to the number of ways, which is 1 head on a coin, which is equal to 1, over the total outcome, 2 sides to a coin, which is equal to 2. So the probability of getting heads is one of those that we talked about that's 50%. It's give or take. So here are a few examples for you. It says, what is the probability that the spinner will stop on part A for number 1? So we need to think, how many outcomes do we have total? Luckily for us, it's divided up nicely, so we have 4. How many of them are labeled with A? 1. So the probability that the spinner will stop on part A is 1 out of 4. Number 2, what is the probability that the spinner will stop on an even number and part B an odd number? Total number 1, 2, 3 becomes our denominator, and then we have to consider how many for part A are an even number. In this case, we only have 1 even number, so part A would be 1/3. Now that you've kind of got the idea, I'm going to leave part B to you, and I also would like you to take a moment and complete part 3 by yourself. These are going to be needed to be included in your notes. I'm going to check to see your answers, and we're going to grade off of that. So, best of luck as we proceed through probability.